So where we left off in our last problem, we had just got our cross-section of the outside of the cylindrical cell. So it's not, sorry, not a cross-section as such. It's the rectangle that's created when you open up your cylindrical shell. So we go to our diagram of our cross, we said cross-section, but it's really just our rectangle there, 2 pi y, 1 minus x. So the formula for that area would be 2 pi y, 1 minus x. And because we're going to be delta y, so our thickness of our cylindrical shell is delta y, we're going to convert the x into square root of y. We expand it out, and there's our formula. There's our volume formula for that section and that shell. So that's come out there. So all the shells start to get summed together, and we're going. Our y values were between 0 and 1. So we get our function as 2 pi y minus y to the power of 3 on 2, and then we integrate that with respect to y. And we go through, do our calculations, we get pi on 5. So we're getting our cylindrical shell, and then we're opening it up and getting our surface area, and then multiplying our surface area by the thickness of our shell. Because remember, it's hollow. So there's our representation of this one, where we've got x squared rotated about the y-axis. So our radius of our shell is what we need. So we can get out, when we open it up, we know what we can get the 2 pi r times the height. Our height is y, because that's the point xy there. So when we go to get our cross section, our length 2 pi x, the circumference of the circle, times the height of y, gives us 2 pi xy. And because it's going to be delta x this time, because we're rotating around the x-axis, our thickness is in terms of delta x. Okay, when we rotate, we take our thickness parallel to the axis of rotation, which is x is equal to 0. So 2 pi xy, and y is equal to x squared for our function. So we do a substitution of y is equal to x squared, gives us a volume function of 2 pi x cubed delta x, which we put into the volume between 0 and 1, because that's where the values of x are, 0 to 1 there. And so integrate that. So our substitution, we get pi on 2. So again, the integration's not that hard this time. We've got this one here where we're going to take y squared, y equals x squared now, and rotate around the line x is equal to 1. So again, our thickness is parallel to the axis of rotation, which is x is equal to 1. So we've got delta x. Again, this time we've got to work out what our radius would be. If that's the point xy, our height would be y, and our radius there, though, if that's the point x, so x to that point, 1 completely to that point, so we're looking at 1 minus x being our radius. So 2 pi r becomes 2 pi 1 minus x, and our height is y. So there's our area formula, 2 pi 1 minus x times the y, and then we do a substitution of y is equal to x squared, because it's going to be in thickness of delta x. So that'll help us give our volume, and again we can use our values there between 0 and 1 again, expand out and integrate, and we can end up with pi on 6. This time we've got x cubed, and the area from x cubed above x cubed to y is equal to 1, and that's rotated around the x-axis. So again, our thickness this time, because we're rotating around the line y is equal to 0, is going to be delta y. We go across, we get our point xy here. So our radius is going to be y. Our height, though, is going to be 1. If that's going to be x there, that's going to be our height. And rotating around between 0 to 1. So we get 2 pi y times the x, and so we do 2 pi y times x, so which becomes 2 pi y times x, which is going to be y to the power of 1/3, gives us our area of 2 pi y to the power of 4/3 times delta y for our thickness. And then we can integrate step between 0 and 1. Allows us to get 6 pi and 7. This time we're taking x cubed to 1, the area there, rotate around the y-axis, or line x is equal to 0, so delta x is our thickness, our point delta xy this time, radius of x, but our height would be 1 minus y, because we're going from 1 to y, and that distance there is y. So we take away the y from 1, that gives us our height and our radius of x. So our rectangle there, 2 pi x, height of 1 minus y. Do the multiplication for our area of that rectangle, and then do a substitution of y is equal to x cubed to get our value there. Multiply it by delta x for our volume, and then we can integrate again between 0 and 1. Pi to x minus x power of 4, 2 pi's just staying out the front, integrate those, and then we're able to get our integration. Question 6 here, this time we've got to rotate around the x-axis, so y is equal to 0, thickness of delta y. Our functions, again, x cubed, cube root of x this time, and 1. So that volume, that's the area there, it's rotated. Take our x and y, so our height there would be x, and our radius, here, we're going from up y. So our cross section, or our shell, opens up to give us a rectangle of 2 pi y times x, and x is, and because it's going to be delta y, we put x in terms of y, and because it's y is equal to cube root of x, x will be equal to y cubed, gives us 2 pi y power of 4. Do the substitution again, between 0 and 1, we had the values when x was equal to 1, y is equal to 1, so that's where we get 0 to 1. Do the integration. This time we've got the same function, but this time rotating around y is equal to 1. So really it's all we're doing is just changing our radii that we're doing, because it's again delta y, because we're rotating around a y value, y is equal to 1. Our radius this time, height scale going to be x, and our radius this time would be 1 minus y, because that's the radius there. So that's the only difference in the question. So it's still from 0 to 1 for the y, limits of integration, and it's 1 minus 1 y times x, and the x was y cubed, gives us that function to set in place and integrate. Question 8, this time we've got 4 minus x squared as our function, and the line y is equal to 4, so this area here is rotated around. So again, we're going to be going delta x, because it's rotating around, x is equal to 0, and our height, well, we look at our radius would be x, our height would be 4 minus the y value there on the curve. So there's our height. We set up our rectangle. We get 4 minus y as the height, 2 pi x as the circumference, because x was the radius. We do the substitution. We get a substitution of 4 minus x squared for y, and expand that out, collect our terms. That gives us 2 pi x cubed, delta x for the volume, and then we're able to integrate between 0 and 2. So that's where we're looking at for our volumes when we use a cylindrical shell. Get that rectangle, make sure we have our radius correct so we can get our circumference as one edge and our height correct as the other. Put them together, make sure we get the correct thickness so we know which function we're integrating with respect to, and then get our limits correct so we can get our correct volume.